Okay, so we're doing systems of inequality. So previously we had talked about systems, like linear systems. So for example, in like 8.2, we did graphing two lines and finding that intersection. So today we're going to combine inequalities, which was B6.7. So if you forgot, go back and take a look. And we're combining that. So we're combining inequalities with like graphing two lines at the same time. Okay, so this is called a system of inequality. The solution is something that works for both of these. So let's look at an example. So is 3, -5 a solution to the system above? So in order to check this, we just have to plug in our x and our y. So I'm going to do it over here. So we do 3 minus -5 is greater than 7, which is 3 plus 8, or 3 plus 5. So that's 8 is greater than 7. So we know that the first equation works. And let's check the second equation. We have 2 times 3 plus -5. Make sure to keep your negatives in order. Make them organized. Parentheses always helps. 6 minus 5 is less than 8. 1 is less than 8. So that is true. Right? So for is 3 -5 a solution to the system of inequalities above? The answer would be yes, because 3 and -5 work for both of these, right? So you sort of want to think about it like a Venn diagram, right? This is like equation 1 and this is equation 2. And pretty much if the point that you choose works for 1 and 2, then it's a solution, right? So you want to have this common ground. And then we're going to check 5, -2. So we do 5 minus -2 is greater than 7. This is the same thing as 5 plus 2 is greater than 7. 7 greater than 7. So that's not true. 7 isn't greater than 7. 7 is equal to 7. If there was a line, then it would be true. But since there's not, this is going to be no. So 3 -5 is a solution, but 5 -2 is not a solution. Okay, so now you want to, remember back in the day when you learned how to graph this. You put it in slope-intercept form. You have either a dashed or a solid line, and then you shade based on a test point or your shortcut, right? So now we're going to do the same thing, but we have multiple lines. Okay, so let's just go straight into our example. I'm going to use colors, so you can use colors if you want. It's more fun, but you can also just do a pencil. So actually, I'll do it with pencil first, and then I'll do it with color. Okay, so the first thing that we want to do is we want to turn this into slope-intercept form. So we're going to move the 3x. So we have 2y is less than or equal to -3x plus 6. Divide everything by 2. So we get y is less than or equal to -3/2 x plus 3. So then we graph it, right? So we start with our y-intercept. We know it's a negative slope, so we're going down. So rise over run. So 3, 2, 3, 2. And since there's a line, we have a solid line. So this is just normal. This is graphing your slope-intercept. And then we shade it, right? So we could put in a test point, or we could see that this is less than. So we're going to go under the line. So we can like shade it. It's helpful to go one direction, right? And then this one, we have x is less than 2. So this one, you want to think of it like x equals 2, right? And these are going to be vertical lines. No matter what y is, x is always 2. So this is going to be dotted. And then since it's less than, like 0 could work. So we're going to shade it like this way. And so you can see the overlapping part is right here. It's this darkest part right here, and that would be your answer. So with colors, it's more fun. So I'm going to make this one green. It's solid. And then you just shade it. And then I'm going to make this one orange. It's dotted. And then you can shade it. You could shade the whole thing, or you could just know that you're only shading the common part. So like if I shaded the whole thing, it would be like this. And then you could see where it overlaps. But if it starts to get too much, you can just shade where you like know the answer is going to be. So the answer set is right here where the colors overlap, right? Like this right here. So this is an easy way to test, right? Like if I was like, is 0, 0 a solution? Well, I can see that 0, 0 is in this combined portion, right? Like 0, 0 would be in this Venn diagram where it's both of them. So I could say, yes, 0, 0 is a solution. All right. So let's try the back one. This one is going to be 3 lines. So I want you guys to try this on your own, and then we'll come back and check. Okay, so let's start with the first one. This is going to be my orange line. Y is greater than... Actually, I'll make it green. Y is greater than or equal to -1. So I'm going to start here at -1, a solid line. And I know that it's greater than, so it's going to be everything above. Right, so I'm doing the method where I shade as I go instead of doing all the lines. So right now I know that my answer can only be in this portion. And then next I'm going to do the next one. I'm going to make this dotted because there's no equal sign. X is greater than -2. So I go here, X is going to be -2. I don't care what Y is. We have a straight line. And I know that it's greater. Okay, so instead of shading the whole thing, I'm actually going to just shade this part because I'm like trying to get it to coincide with the green. So right now I know my answer can only be, you know, above the green and to the right of the orange. It wouldn't be wrong if you shaded this bottom part in like the peach color. But I'm just doing it to make it a little cleaner for me. And then this last one, I have to make it into slope-intercept form. So I minus the y from both sides. I get 2y is less than or equal to -x plus 4. Divide everything by 2. We get y is less than or equal to -1/2 x plus 2. And be careful, there's not a lot of these in the examples, but remember, if you're dividing by a negative, you need to switch the sign. So I haven't seen that rule come up in a lot of the sample problems, but you can't forget it because it still exists. So we have our y-intercept of 2. Our slope is -1/2, so down 1 over 2. Remember you're thinking, right? My slope is negative, so the line should look like that, not like that, right? You're going downhill. It's a solid line. You could use a ruler, or you could just freehand it. Ruler is probably better. And it's less than, so it's going to be below the line. So I'm actually just going to shade this part here. And I can clearly see that my boundary is like a triangle, right? So this is all the points that are allowed. So anything in this triangle is a solution. If it's on this dotted line, then it's not a solution. But if it's on either of the solid lines, then it is a solution, right? So for example 4, you're going to use this picture here and just, you know, the answer should be a yes or a no for the solutions. So work on that and then come back to the video. So for this one, all you have to do is check, right? So 0, -1, it's not even in the shaded area. It's just on that dotted line. So that's going to be a no. 2, -2, so we go 2, -2. That's in the shaded area, so that's a yes. 2, -5. This is on the dotted line. So remember, dotted, it has to be in the boundary. So since it's not a solid line, this is actually going to be no. And then 3, 0, this is the example of the other one, right? It is on the dotted line, or it is on the solid line, so this one's going to be a yes. Right? So make sure you're very careful with your dotted and straight and solid lines, and that's why it's really important to graph it carefully too. All right, our last example we can do together. So we have, they're both already in slope-intercept for us, which was very nice. This one I'll do in green, it's dotted. This one I'll do in orange, it's solid. So we're going to start with our y-intercept at 1. Our slope is 1/2, so we know the line should be going up. We go up 1 over 2. Dotted line. And then it's saying it's greater than, so it's going to shade above the line. And if you're not sure, just test a point, right? Like if I wanted to test 0, 0, 0 less than 0 plus 1, 0 is greater than 1. Okay, so 0 is not greater than 1, so it can't be, 0, 0 is not in the solution set, so it's going to be above. And then we graph this orange line. We have -2. Our slope is the same, which should give you a warning. It's a straight line. This one is less than or equal to, so we're going to go below it. So there's no overlapping part right here, so this is a no solution. Which you sort of saw in B08.4 for linear equations. Okay, so just to give you like a what if this had been switched, right? So if it had been y is greater than 1/2 x minus 2, then the shaded part would have been up here, and then the overlap would have just pretty much been the green part. So if you had switched it, the solution set would be just the green, really, because the orange would encompass everything, including the green. So there's lots of different situations. Sometimes it's a nice shape like this triangle. Sometimes there's no solution. Sometimes it could have been the other side of the pink, and it would have been like just this like ugly shape that goes on forever. So you just want to be really careful with the directions, and you can always test a point, right? Like I could test 0, 0 here. Right, so if I put 0, 0 minus 0 plus 1, and 0 less than or equal to 0 minus 2. So this is saying 0 is greater than 1, 0 is less than or equal to -2. So both of these are false, right? Or no. So clearly the 0, 0 point is not allowed to be in the solution. And as you can tell by the graph, it's not.